Now we're going to talk about even symmetry. So I have 4 examples, and I hope that this will illustrate what even symmetry is. Basically, it's just when you have a function, if it's symmetric with respect to the y-axis. In other words, the y-axis acts like a mirror, and you can see that both sides are the same. So the y-axis is giving you, on the left is the mirror image of the right and vice versa. So this function is even because it's symmetric with respect to the y-axis. And I write with respect to WRT. So you can tell a function is even symbolically by substituting negative x into your function. And if you get the same function out, then you've got an even function. So here we could say f of minus x equals minus x squared. And when you square a negative, you get a positive. So that means that f of minus x equals x squared. And since they're identical, we know it's an even function. And so you can either look at the graph and determine, is it even because of the symmetry, or is it even symbolically by plugging in negative x? And that just means that on the negative side of the graph, your y values are the same as on the positive side. And that's why you have the symmetry like that. This also is a symmetric with respect to the y-axis. So this is also an even function, okay? And if you take f of minus x, you're taking the absolute value of minus x, and that's just the same as the absolute value of x. The negative gets absorbed by the absolute value. So this is an even function, and it's symmetric with respect to the y-axis. Now, here we have a parabola, just like we have here, but as you can see, it's shifted over by 3 units to the right. So it is not an even function anymore. And you'll notice that if I try to look at this symbolically, I would say f of minus x equals minus x minus 3 squared. And that is not the same as this. In fact, you can factor out that negative and you would get negative 1 times x plus 3 and the whole thing squared. But when you square the negative, it becomes a positive. So it's just plain old x plus 3 squared instead of x minus 3 squared. They're not the same. So this test fails. It fails the test. So it's not even. But also, if you were to take the mirror image of this, you'd have a parabola over here. And whereas here, if you take the mirror image, if you flip it, you just get the same. Now, here we have the square root of x, and if you take f of negative x and plug it in, you would get the square root of negative x, and that is not the same as the square root of x. So this is not even. And you can see that by the graph as well. If I flip it over, I get a different function. Whereas here, if I flip it, and this one, if I flip it, I get the same function. So that is how we do it graphically to determine if the function is even. In other words, if it's symmetric with respect to the y-axis, or symbolically. Those are the 2 ways you can approach that.